All right, today we're diving into something pretty wild. We're unpacking a report on a book with a claim so big it literally questions the ground beneath our feet. And yeah, it challenges pretty much everything we know about modern science. So let's just jump right in.
Okay, I want you to do something for me. Just for a second, forget everything you learned in science class, and just ask yourself, what if the Earth doesn't move? Like at all? What if it's not a spinning globe flying through space, but it's just stationary? That's the huge, mind-bending question at the heart of what we're looking at today.
So where does this idea come from? Well, it's from a book by Hendrie, and the title says it all, The Greatest Lie on Earth. And look, the report we're drawing from makes it really clear. This isn't some small debate over details. No, this is a full-on challenge to hundreds of years of science as we know it. And the book's main point? It's incredibly direct. It basically says that everything we take for granted, the Earth spinning, orbiting the sun, is all built on a shaky foundation. The author claims there's no solid, undeniable proof for any of it. So let's just be super clear about the central argument. It's that our planet is totally fixed. It's motionless. And all that stuff we see in the sky, the sun rising and setting, the moon going through its phases, the stars spinning overhead, that's not us moving. Nope. According to this book, all of that is happening around a completely still Earth.
Okay, so you're probably thinking, how on earth do you even begin to support a claim like that? Well, the strategy here is really interesting. It's not about finding new evidence. It's about taking things we already know and saying, hey, we've been looking at this all wrong the entire time.
The book looks at a bunch of things we can all see and experience. Like the way a Foucault pendulum swings back and forth, or the fact that when you look out over a huge lake, it looks completely flat, right? No curve. The author takes these observations and reframes them as evidence, and you can see why it's compelling. It's based on what our own eyes tell us, arguing these are clues that the Earth isn't moving.
And this slide really gets to the heart of the conflict. Take the Coriolis effect. Mainstream science points to it. It's what makes hurricanes spin and drives ocean currents and says, see, that's proof the Earth is rotating. But Hendrie's critique completely flips that. It argues the effect is totally misinterpreted and doesn't prove a thing. It's the same data, but two completely opposite conclusions, a total clash.
But this all leads to a massive, glaring question, doesn't it? If the Earth is actually stationary, why would anyone go to the trouble of pretending it moves? And this is where the whole argument takes a turn, away from just science and straight into the idea of a massive conspiracy.
I mean, it's the obvious next question. The globe model is literally everywhere you look. School classrooms, NASA photos, the GPS in your phone. If it's all one big lie, the book has to have an explanation for all that.
And the author's answer is, it's not some accident. It's not just a scientific mistake that we never got around to fixing. No, the book presents it as a calculated, intentional deception, one that's designed to control what we think and how we see our place in the universe. So who's behind this supposed lie? Well, the book points fingers at the biggest institutions you can think of. First, the schools that teach it to us as kids. Then, the entire scientific community that says, yep, it's true. And finally, the governments and organizations that pour money into it.
Okay, so that's the book's provocative claim in a nutshell. Now let's shift gears a bit. Let's zoom out and see how the report we're working from actually analyzes all this. It takes a much broader look at how science operates and, where an argument like this even fits into the picture.
The report doesn't really see this book as just a competing scientific theory. Instead, it frames it as something else, the intersection of two really powerful ideas. On one hand, you've got this deep, deep skepticism of authority. And on the other, you have the belief in a massive, coordinated conspiracy. Now, to really get the mainstream scientific perspective, we need to talk about what scientific consensus actually means. And it's super important to know this isn't just a vote or a popularity contest among scientists. It's what happens when mountains of evidence, coming from all sorts of different fields, all start pointing to the exact same conclusion. And that's exactly how we got the consensus on a moving Earth. We're not talking about one single experiment. We're talking about centuries of work in physics, astronomy, geology, even GPS satellites and space travel, all of it independently confirming the same model. It's like a giant web where every strand of evidence from one field supports all the others, making the whole thing incredibly strong. Which brings us to the main takeaway from the report. The point isn't to say don't ask questions, not at all. The point is that you have to take any new claim, no matter how interesting or compelling it might seem on its own, and you have to weigh it against the enormous amount of evidence that's already there.
In the end, the report suggests that looking at claims like this, even when they're way outside the mainstream, is actually useful because it forces us to step back and ask some really big questions, like, what do we actually count as evidence? How do we really know the things we think we know? And where do we draw the line between a fact and a belief?
And that really is the question at the heart of this whole thing, isn't it? Skepticism is vital. It's what drives science forward. But at what point does healthy skepticism become something else? When does it become a refusal to accept overwhelming evidence coming at you from every possible angle? That's the line we're all trying to find. Something to think about. Thanks for joining us.